NASA scientists thought it was over. The object was leaving. It had already survived its closest brush with the sun. It was already fading, already shrinking into a faint smudge on the edge of detection, already heading back out into the dark between stars where it came from, and where it was never supposed to be seen again. Then, without warning, it lit back up. Not a little. A full-blown eruption of gas and ice, blasting out into space at a rate that stunned the researchers watching it happen. And a few months after that, a second signal arrived, one that had been sitting in transit for months, carried across hundreds of millions of miles by a spacecraft that wasn't even supposed to be looking. When it finally landed on Earth, it showed something nobody had seen before. The exact moment this visitor from another star came the closest it would ever come to our Sun, caught in more detail than any interstellar object in human history. NASA has now confirmed both events, and together they've turned an object everyone thought was quietly leaving into the single best documented visitor humanity has ever received from beyond our solar system. This is the story of 3I Atlas and why it just came back. Before we get into it, if you're new here, this channel breaks down real space discoveries the way scientists actually talk about them, without the exaggeration. If that's your kind of channel, hit subscribe right now. It genuinely helps this reach more people who care about getting the science right. And by the end of this video, I want to hear what you think is really going on with this thing in the comments, because even NASA's own scientists are still arguing about parts of it. Let's set the stage properly, because the buildup matters here. On July 1st, 2025, a survey telescope in Rio Hurtado, Chile, called ATLAS, the Asteroid Terrestrial Impact Last Alert System, caught a faint point of light moving in a way nothing in its catalog matched. Within days, astronomers confirmed it wasn't orbiting the Sun the way every comet and asteroid native to our solar system does. It was moving on a hyperbolic trajectory, a wide, open arc, the signature of an object that came from outside the Sun's gravity entirely and was only ever passing through. It was named 3I Atlas. The I stands for interstellar. The 3 means it's only the third such object humanity has ever confirmed, after Oumuamua in 2017 and Borisov in 2019. When it was found, it was already about 410 million miles from the Sun, still inside Jupiter's orbit, moving fast enough that researchers immediately knew this wasn't something our own solar system had flung outward. It had arrived already moving that way. Later analysis of older sky survey images actually found faint traces of the object going back 55 days before its official discovery date, meaning it had been sitting quietly in astronomers' data the entire time, completely unnoticed, until someone finally knew what to look for. By October 2025, researchers had also worked out its orbital eccentricity, a number describing exactly how stretched an orbit is, and it came out to roughly 6.1, making 3I Atlas more extreme in its trajectory than either of the 2 interstellar visitors that came before it. Of the 3 confirmed interstellar objects humanity has ever detected, this one is moving through our solar system on the least bound, most aggressive path of the group. Further proof that whatever accelerated it long before it ever reached our Sun had nothing to do with anything inside our own solar system. Over the following months, NASA turned nearly everything it had toward this object. Hubble measured its nucleus. Webb broke its light apart to read its chemistry. The comet swept past Mars on October 3rd, close enough that NASA's Perseverance rover and multiple orbiters caught images of it, the closest any spacecraft had ever gotten to an interstellar visitor. It reached its closest approach to the Sun on October 30, 2025, passing at about 130 million miles, just inside the orbit of Mars. And then, for roughly a month, it disappeared. Its position lined it up directly behind the Sun as seen from Earth. a configuration astronomers call solar conjunction, and no ground-based telescope on the planet could observe it safely. It re-emerged on the other side in early November. By December, with the comet now visibly moving away from the Sun and heading back out toward interstellar space, most people assumed the exciting part of the story was finished. The headlines had already been written. The comet had made its pass, survived, and was leaving. That is exactly the moment everything changed. If you're the kind of person who wants space stories explained clearly instead of buried in jargon, drop a like right now. It genuinely helps this reach more people who'd enjoy it. The first beat. The comet that was supposed to be fading flared instead. In December 2025, NASA's SPHEREx mission, an infrared space telescope designed primarily to map the entire sky rather than chase individual objects, happened to catch 3I Atlas in its field of view as the comet continued its outbound journey. What SPHEREx found did not match the expected script. A comet moving away from the Sun should be cooling down, its activity tapering off as it gets less sunlight to vaporize its ices. Instead, 3I Atlas had developed a fresh glowing coma, rich in water vapor, carbon dioxide, and organic compounds, and had grown a distinctive pear-shaped dust tail, evidence of rocky material actively being blasted off the nucleus. Researchers described it plainly. Instead of fading quietly into the dark the way everyone expected, the comet was erupting. This wasn't a slow decline. It was a genuine outburst, happening on an object already well past its closest approach to the Sun, at a distance where solar comets are typically calming down, not lighting up. What made the SPHEREx detection especially valuable wasn't just that it happened. It was what it let scientists do with it. Because infrared light can separate individual molecules by their specific wavelength signatures, the outburst effectively handed researchers a fresh, uncontaminated sample of exactly what this 10-billion-year-old ice was made of, without needing to wait for the comet to make another close approach that will never come. Every molecule SPHEREx picked up in that unexpected flare-up became one more confirmed data point about a chemical environment from a completely different corner of the galaxy's history, gathered essentially for free from an event nobody had scheduled or predicted. That alone would have been a strange enough story on its own. But it turned out to be only the first half of what NASA was about to confirm. The second beat is where things get genuinely remarkable, and it involves a spacecraft that was never even supposed to be the one telling this story. The European Space Agency's JUICE spacecraft, short for Jupiter Icy Moons Explorer, was already deep into its multi-year journey toward Jupiter's icy moons when 3I Atlas was discovered in July 2025. JUICE wasn't built or positioned for this. But its science team realized the spacecraft happened to be in a position to catch a glimpse of the comet using its onboard instruments, including a camera system called JANUS and a spectrometer called MAGIS, the Moon's and Jupiter Imaging Spectrometer. The team scrambled to plan unplanned observations, working around a genuinely difficult challenge. JUICE was, at the time, positioned on the far side of the Sun relative to Earth, forced to transmit its data through a slower backup communication system. Whatever JUICE managed to capture wasn't coming home quickly. The observations happened right around the comet's closest approach to the Sun in late October 2025, a window Earth-based telescopes couldn't observe directly because the comet was, at that exact moment, lost behind the Sun's glare. JUICE had a vantage point nobody else had. And then the team waited. And waited. The data didn't fully reach Earth until February 2026, nearly 4 months after JUICE actually captured it. When it finally arrived, scientists got their first real look at what 3I Atlas was doing at the single most violent moment of its entire passage through our solar system, the moment nothing else could see. Pasquale Palumbo, an Italian National Institute for Astrophysics researcher and the principal investigator for the JANUS camera, described the wait as genuinely worth it. The images revealed an extended coma, a visible tail, and detailed structures within it. Rays, jets, and filaments, streaming off the nucleus in patterns nobody had captured this clearly on any interstellar object before. And the MAGES spectrometer data, once fully analyzed, delivered a number that stunned the team. An outflow of roughly 2 tons of water per second pouring off the comet's nucleus, equivalent to about 70 Olympic swimming pools of water vapor released into space every single day. Team member Giuseppe Piccioni put it in blunt terms. Repeated detections of water vapor and carbon dioxide showed that ices buried beneath the comet's surface were being actively torn open and released into space in the direct aftermath of its closest solar approach. To put that number in perspective, an earlier study using NASA's SWIFT observatory, published in September 2025, while the comet was still approaching the Sun, measured a water loss rate of around 40 kilograms per second, described at the time as comparable to a fire hose running at full blast. That measurement alone was considered remarkable, because it showed the comet was already actively losing water at a distance from the Sun, where most solar system comets haven't even switched on yet. JUICE's later measurement, taken right at the moment of closest approach, was roughly 50 times higher than that early figure. The comet hadn't just started leaking. It had, for a period, been genuinely erupting. Think about what actually had to go right for that data to even exist. JUICE wasn't launched for this. It's a multi-year mission bound for Jupiter's icy moons, carrying instruments designed to study worlds like Europa and Ganymede, not to chase a comet nobody knew existed when the spacecraft left Earth. A team of scientists had to notice the opportunity, replan observations on short notice, point instruments built for an entirely different target, and then simply wait for months while the spacecraft finished its own scheduled trajectory and slowly worked its way back into range of a stronger communication link. If any part of that chain had failed, this particular window into 3I Atlas's closest approach, the one moment Earth-based telescopes physically could not see, would have been lost forever, with no way to ever go back and capture it again. The third beat is where NASA's own chemistry data started raising questions nobody could fully answer. While JUICE's data was still in transit, NASA's James Webb Space Telescope had already been reading the comet's chemical fingerprint directly, and what it found didn't match the profile of a normal solar system comet at all. In a typical comet from our own solar system, water vapor dominates the outgassing, since water ice is the most common frozen material comets carry. That is not what Webb found here. The coma of 3I Atlas was overwhelmingly carbon dioxide, and Webb also detected fine water ice particles and carbon monoxide gas woven through the mixture, a genuinely layered, complicated chemical cocktail. Later observations added methane to that list, and researchers found the methane-to-water ratio was roughly 11 times higher than anything ever measured in a previously studied comet, solar system, or otherwise. A carbon dioxide and methane-dominated coma like this points toward an object that formed somewhere extremely cold, far colder than the region of our own solar system where comets typically condense. Then, on June 22, 2026, a team led by Martin Cordiner at NASA's Goddard Space Flight Center published the result that finally explained why this comet's chemistry looked so unfamiliar. Publishing in the journal Nature, Cordiner's team used Webb's data to measure the ratio between two forms of carbon in the comet's gas, ordinary carbon-12 and the heavier isotope carbon-13. That ratio shifts slowly and predictably over cosmic time as generations of stars live, die, and enrich the galaxy with new material. What they found was a ratio containing far less carbon-13 than anything ever measured in our own solar system, or in any young planet-forming disk observed around another nearby star. Working backward through models of galactic chemical evolution, the team concluded that 3I Atlas most likely accreted its ice somewhere between 10 and 12 billion years ago, during an unusually active early period of star formation in the galaxy's history that astronomers call cosmic noon. For comparison, our own solar system is roughly 4.6 billion years old. This object may have been drifting through interstellar space for longer than our Sun has existed at all. Cordiner told reporters at the time that it might be the oldest object ever directly observed passing through our solar system. The fourth beat is the one that actually pulled this story out of academic journals and into worldwide headlines, and it deserves a completely honest breakdown. In October 2025, researchers using the UVES spectrograph on the European Very Large Telescope in Chile detected a plume of nickel vapor coming off the comet, later corroborated using the Keck 2 telescope in Hawaii. Nickel vapor by itself isn't unheard of in comets. It's been detected before, including in Borisov. What made this different was what was missing. Nickel and iron are normally found together in comet outgassing, forged together inside dying stars, and they typically travel bound to each other as what researchers sometimes call cosmic twins. In 3I Atlas, the nickel signal was strong. The iron signal was almost completely absent. Several published papers describing the detection used words like extremely puzzling, because comets are generally far too cold at these distances for solid metal grains to simply evaporate into gas, and nothing in the existing solar system comet record looked quite like this specific imbalance. The leading natural explanation involves a class of low-temperature nickel-bearing compounds, potentially something like nickel carbonyls, that could release nickel atoms under much weaker sunlight than would ever be needed to free iron from its own more stable compounds. It's a real, if previously undocumented, chemical pathway, and most researchers studying the comet consider it the most likely explanation, especially since faint traces of the same nickel-dominant pattern, though far less pronounced, were also spotted in Borisov, suggesting this might be a genuine feature of comets that form outside our solar system, rather than something unique to this one object. It's also the detail that launched a much louder conversation. Harvard theoretical physicist Avi Loeb, who has spent years studying possible technosignatures, publicly raised the possibility that the unusual chemistry, combined with the comet's trajectory passing unusually close to the plane where the planets orbit, could point towards something artificial. It's important to be direct about this. That position remains a minority view within the scientific community. The overwhelming majority of researchers working directly with this data, including the teams behind these actual detections, favor natural chemical explanations tied to the comet's ancient, extremely cold formation environment. And it wasn't just dismissed from an armchair. A team of researchers pointed the Allen Telescope Array, a radio observatory specifically built to search for potential artificial transmissions, directly at 3I Atlas during its passage, systematically scanning a wide range of radio frequencies. The result was a clean, complete non-detection. No artificial signal, at any frequency the array could monitor. When a legitimate scientific question was raised, the response wasn't speculation. It was an actual instrument, pointed at the actual object, and an honestly reported result. The fifth beat brings the story back to where we are right now, and this is the part that genuinely justifies calling this comet back. As of mid-2026, 3I Atlas is well past Jupiter's orbit, continuing to recede on its way out of the solar system forever, moving fast enough that it will never slow down, never turn around, and never return. It is currently sitting in the constellation Gemini, fading rapidly, already too faint for most backyard telescopes to pick up. By every reasonable definition, it is leaving. And yet, in the span of a single year, NASA has now confirmed two separate, genuinely surprising developments involving this object almost back-to-back. A real measured outburst captured by SPHEREx in December, showing the comet actively erupting instead of fading on schedule, and a flood of new, previously hidden data from JUICE, delayed for months in transit, that only reached Earth and got fully analyzed in February 2026, revealing the most detailed direct look at an interstellar object's closest solar approach that any spacecraft has ever captured. Two returns in one story: the comet's own unexpected return to activity and its data's literal return to Earth after a 4-month journey across the solar system. It's worth being precise about what all of this actually confirms, versus what remains genuinely open. Confirmed. 3I Atlas underwent a real, measured outburst in December 2025 that defied the expected fading pattern of a comet moving away from the Sun. Confirmed. JUICE captured, and NASA and ESA have now released the most detailed data ever obtained on an interstellar object's behavior at closest solar approach, including a water outflow rate of roughly 2 tons per second. Confirmed. The comet's carbon isotope ratio points to an age of 10 to 12 billion years, making it very likely the oldest object ever directly studied passing through our solar system. Confirmed. A dedicated radio search found zero evidence of anything artificial. Still genuinely debated. The exact chemical mechanism behind the nickel without iron signature, though the natural explanation remains far and away the leading one. NASA and the European Space Agency have also both been explicit and consistent throughout this entire event. 3I Atlas posed no threat of impact at any stage of its journey, and it never came anywhere near close enough to Earth for that to be a realistic concern, its closest approach keeping it roughly 270 million kilometers away, more than 700 times the distance between Earth and the Moon. So here's why any of this should genuinely matter to you, beyond the fact that it's a great story. Every comet native to our own solar system formed from the same disk of material that built our planets, which means studying them mostly tells us about our own local chemistry, over and over again. 3I Atlas is different, in a way that almost nothing else humanity has ever studied is different. It's a physical sample of material that condensed around conditions from an entirely separate part of the galaxy's history, drifted untouched for over 10 billion years, and only now, for the first time, got warmed up enough by our own Sun for us to actually measure what it's made of. The outburst SPHEREx caught, and the eruption JUICE photographed up close, aren't just dramatic footage. They're direct evidence of exactly how volatile ancient ice behaves when it finally gets exposed to a star. After more than 10 billion years of untouched cold, data planetary scientists have never had access to before, from any source, at any point in the history of astronomy. It also reframes something scientists had mostly treated as a one-time event. When 3I Atlas was first discovered, the working assumption was simple. Watch it approach, watch it round the Sun once, watch it leave, and treat the whole event as a single narrow window that either gets fully captured or gets missed. What the December outburst and the JUICE data both prove instead is that an interstellar object passing through our solar system isn't necessarily one clean observation window. It can behave unpredictably even after the main event is supposedly finished, and useful data can keep arriving in unplanned bursts, from unplanned instruments, for months after everyone assumed the story had already been fully told. That's a genuinely useful lesson for the small community of astronomers already preparing for the next one. Vera Rubin Observatory in Chile, now fully operational and built specifically for exactly this kind of wide, fast sky survey, is expected to catch interstellar objects far earlier in their approach than Atlas ever could with 3i Atlas, giving scientists more lead time to plan exactly the kind of opportunistic multi-spacecraft coverage that ended up making this particular story so unexpectedly rich. As for what happens next, the timeline from here is straightforward, if a little bittersweet. The comet will keep fading as it moves further from the Sun, and astronomers expect it to become effectively unobservable to most current instruments before too much longer, permanently. Because it spent so long drifting between stars, researchers say it's essentially impossible to trace 3i Atlas back to the star system it originally came from. That star may not even exist anymore. What we're left with instead is exactly what NASA just confirmed: a full, detailed data set, gathered from Hubble, Webb, SPHEREx, an unplanned assist from a Jupiter-bound spacecraft that happened to be in the right place at the right time, and ground observatories around the world, capturing a piece of another part of the galaxy that happened to drift close enough for us to actually study it, once, before it disappears for good. Here's the detail I want to leave you with. Somewhere out past Jupiter right now, moving away from us at tens of kilometers per second, there's an object carrying chemistry that was locked into ice before our own sun had even finished forming. And for a brief window at the end of last year, while almost nobody outside the astronomy community was paying attention, it lit back up one more time before it left, giving NASA its clearest, most complete look yet at a piece of another star system, an event caught almost by accident, by a spacecraft that wasn't even supposed to be watching. It will never come back. But the story didn't quietly end the way everyone assumed it would back in November. It came back first, one final time, and NASA just confirmed exactly what that meant. If this kind of deep dive into real source space science is what you come here for, hit subscribe. It genuinely helps this channel keep making them. And I actually want to know what you think down in the comments. Does the nickel without iron signature sound like natural comet chemistry to you? Or does it make you lean toward Loeb's minority theory even a little? Scientists are still debating it, so don't hold back. Drop your take. And if this blew your mind even a little, send it to the one friend you know is going to nerd out over this as much as you just did.